The operating temperature of 40 watts 110 volt filament lamp is 20 degrees Celsius. The filament is made of a 0.01 millimeter diameter wire having resistivity of 6 by 10 raised to negative 6 at 20 degrees Celsius and a temperature coefficient of 0.005 at 20 degrees Celsius. We need to find the length of the filament. So let's try and solve. We have here our given. So the given is the power, which is 40 watts, voltage of 110 volts, and our our temperature number number 2, or the final temperature, which is 20 degrees Celsius. Also, we have the diameter of 0.01 millimeter, resistivity of 6 times 10 raised to negative 6 at 20 degrees Celsius, and then our temperature coefficient, which is 0.005 at 20 degrees Celsius. So we are tasked to find our length of the filament. Okay, so let's go ahead. So we have here the formula. What formula do we have to use? First, we have to get resistance using this one. So P is equals to IV, right? And V is equals to IR. So I is equals to, therefore, I is equals to V over R. So, let's substitute I. We have P is equals to V over R multiplied by V, or simply P is equals to V squared over R. It's because I don't memorize all the Ohm's law, so I just memorize 2 of them and then I just manipulate them. So we have the power of 40 watts is equals to 110 volts. 110 squared all over R, which is the missing part. And then, using calculator, we have 40 is equals to 110 squared all over X. Shift solve. We will obtain the value of our resistance, which is equivalent to 27.5. I mean 302.5. Sorry. We have the value of 302.5. Okay? So with that, let's go ahead and write in our formula for resistance. We have R2 is equals to R1, 1 plus the temperature coefficient multiplied by T2 minus T1. So we have 302.5 is equals to X1 plus 0.05 multiplied by 2020 minus 20. So our x value would be equals to 302.5 is equals to x plus 0.005 and 20 minus 20. So we will obtain the value of 27.5 ohms. That would be our R1. That should be our R1. Okay? But in calculator, we use X because there is no variable R1 there. So, also, we have to find the length. So, we will use another formula of resistance, which is R is equals to rho L over A. So we are given the resistance, which is 27.5 is equals to the rho, which is 6 times 10 raised to negative 10. Negative 6, I mean, right? Negative 6. And our length, which is the missing part, all over the area. What is the area? Area is so the area of a wire. So the wire is a circular area, which is equivalent to pi over 4 d squared. Our diameter is in millimeter. We have to make it in centimeter, right? We have to make it in centimeter. Okay, so our area is equals to pi over 4 0.01 millimeter, right? 0.01, yes, and 10 millimeter is equals to 1 centimeter. So this should be squared, this one is cancelled. So area will become pi over 4 multiplied by 0.01 all over 10 raised to 2. So we will obtain the value of 7.853 times 10 raised to negative 7. And so we got the value of A, which is 7.853, right? Times 10 raised to negative 7 centimeters squared. So let's plug it in our area, which is therefore our L value is, we just have to shift solve it, okay? So we have 27.5 equals to 6 10 raised to negative 6 x all over 7.85. So our answer will be 3.5975 or approximately 3.6. That would be the final answer.